Actually, as it turns out, this is what I've done the most in my, as far as like techniques. I've spent a lot of time soldering my life. I'm a ham radio operator, I've been soldering for ages. So let me do this for, in fact, there's a funny story. When I did my first kit, it was a Heath kit, HW101 ham radio. And I didn't know what I was doing at all. And I had worked all summer to get money for this kit. And I was 15. And a friend taught me how to solder. He was going to teach me how to solder. And you might know how that is when two 14-year-olds try to teach you. And he told me, he said, well, what you do is you drip the solder, oh gracious, you drip the solder onto the joint that you want to make. And so I'm using a heat gun, like a wood burner, and then I'm trying to drip solder on there like he taught me. And I thought, this is ridiculous. This isn't working at all. And I read the instructions. So anyway, this is a painful part of my youth. So this is a rosin core solder. So the flux that we applied on the copper tubing is inside this. It's a natural product. It's healthy for you. It comes from pine trees or something like that. So usually when you solder, you get a little smoke and you kind of blow on it to keep it away from you. But this is really pretty simple. The trick is to heat all the metal you're trying to solder. And I'll mention too, this is normally tin. This is kind of in rough shape, but you can tin this, and you can see it's a little bit shinier now. I ran it across a damn sponge. And there's some other things you can do with it. You can put it like an ammonia, there's a kind of ammonia block that helps get rid of the oxide. So it's all about getting rid of the oxides on all this stuff, including the solder. And what else to tell you? Normally, unless the copper's in bad shape, you don't have to sand it. If it's been really oxidized, you can. But basically, you're heating this together. I know it's hard to see from the cheap seats there, but I'm heating it, and it depends on the wattage of the soldering iron as to how long you do it. And then you apply a little solder. And then I give it a little flare, and it's got to cool for a little while. But if you look at that, go ahead and pass it. Let me make sure it's a good solder joint. Yeah. What you don't want to see is a meniscus of any sort. Any kind of hard edge coming into the copper. It should be smooth and tapered right into the copper. So that's a good joint.
It should be shiny.
And it should be shiny. That's right. And then this is, so that's how you connect wires. So for example, this is an electrolytic capacitor. So for me to solder this, I could use. And again, the more fun part of this is doing it yourself. So typically, if you're soldering into a breadboard of some sort, you pull the legs apart a little bit, like I did right there, so it's mechanically held. And then you do the same process. I'll mention too, some parts are very valuable, so you don't want to apply too much heat to them, and people get all philosophical about that, about how hot the soldering iron should be. So for example, if you're doing integrated circuits, you don't want too much heat on them, and that's why some of them, especially for do-it-yourself projects, will have sockets, so you can solder in a socket which is not heat sensitive, and then you snap in the integrated circuit. But basically you want to be as fast as possible with the soldering operation. So one trick is you can tin, like if you notice on the boards that you have, there's actually solder already on there. Instead of bare copper, there's already solder that's been fused to the copper. It makes the soldering much, much easier. That's not, like the wires I passed, of course, did not have that, but it makes these circuit boards a lot easier to solder. So what I'm going to do is I'm going to put the tip of the soldering iron on the wire and on the base here. And I'll let the heat work its way in, and then, whoops. And that's all there is. If you notice, I pulled it up the tail, because well, this is what I do. That's good. And then I would trim the end off. I'd snip it flush, and I've got a joint. And what's nice is you can look at it and you can trust it. Yay. When you're doing hundreds of joints, which you do in a lot of projects, it's very easy to make mistakes, you know. So you really want to look at each joint. Less solder is good. When I first started soldering, I thought more is better. And you get solder bridges, which is probably bridges between two joints, and it's hard to see. I'll mention too, there's these other tools.
Sorry, yeah, but you also have to watch the top side, because if this is a double layered circuit board,
yes, that one is,
then you would not have contact on the top side here unless the solder flowed through, because one side of the board may be part side A and the other side may be part B, and the electrons have to go from side to side.
Right, that's a double-sided board, which is harder to work with for hobbyists. So normally we wouldn't use that so much. But a couple other tools. This is a solder sucker, which is a lot of fun. If you make a mistake, I hardly ever use these, quite frankly. But what it does, you cock it in and you push the button, and it creates a vacuum. So you can heat up the solder, and well, anyway.
Fill a hole on the circuit board.
Yes, it's anti-matter. All right. Anyway, so you heat up the solder, the joint, and then once it's molten, you can pop that. Now they used to just use like the bulbs you use on babies' noses, but now it's all this fancy stuff. So there you go, you pass it around. There's really not many other tools to solder. There's some ways to prepare the solder, the tip of the soldering iron, and these are replaceable. So you want it to be shiny, and when it gets kind of blackened, it means it's not going to solder as well, and the heat might not be applied uniformly. So this is dangerous. It's like a torch. You can burn yourself, and it's.
Oh yeah.
This has adjustable heat,
Was gonna do that.
and I'm trying to think what else to share with you. That's
That was probably me.
yeah, those are. And solder, like this is solder too. This is really a beautiful solder. It's very small, so it melts very easily. So you get different diameters. I usually use this diameter, but that's a really nice solder. We got a ton of it here, so that's good. So what I propose for use is
also lead-based.
small. That's lead-based?
I don't know.
Oh.
There's also lead-based and non-lead.
Yeah. Hopefully the lead base is gone, because that's, you're right. And there's a big discussion about how much tin to have in soldering. You can get into these metallurgical debates, which are always fun.
You don't need to use flux with that?
This has flux in it.
Flux core.
Because of the rosin.
Yeah. Yep. In fact, that's what the smoke is. And the flux is the rosin, and it's what makes that smoke. And it melts before the solder. So it's really cool, because the rosin gets in there, does the deoxidizing of the copper, and then the solder melts soon thereafter in perfect orchestration. And for us who use it, it's just luck. It's just we just do our thing, and the chemists get to make their chemicals do their thing. Okay, so I thought we could try this, and the easiest thing to do is we have. I'm trying to think how to do this. The easiest way to do this really is to strip wire, I think as a starter. I'm not many people this works out. Is to go ahead and strip a couple pieces of wire, and this takes a little more heat. And this is just fun. Go ahead and twist them together, and then because you can hold it. Well, actually, it'd actually be better if we work in teams, because some person can hold the other person. Because you need one hand to hold and the other to solder. So this is going to take more heat than the circuit board. So I'm going to leave the heat on there, let us do its work. And then what's nice with this though is you can see it flow. So I'm going to apply the solder to the opposite side of the joint. And I guess as we're waiting for the heat to transmit, you should know that the solder shouldn't be used for mechanical strength, even though it does impart some mechanical strength. And there's this is a small soldering iron for this big wire. So.
Get it going by hitting the iron with it.
Yeah. No, you're right. I'm going to crank it up a little bit. There's soldering guns that have a little more horsepower. Yeah, that's taking a lot of heat. Okay. We can use a thinner wire. But this is nice because you can see it flow. Wow, I'm just not getting that. Actually, that works. I think what might be nicer is to just do. That's a good first step, and then the second step is with the breadboard. It's quite different than soldering, but it's the same idea, and then you're using a solder, which is an alloy, but tin is the most important one. It produces an intermolecular bonding that gives good fusion between the solder and the copper itself. So the prep for copper, and I'll pass this around before we go, is to clean it. Mechanically, we're trying to get rid of oxide surfaces that interrupt this intermetallic bonding, and then you use the solder and heat and so on. But before we get to that, this is hard copper. This is soft copper. It's ACR copper, air conditioning refrigeration copper. It's one of my favorite things. You can do sculptures with this. You can bend it by hand, and you can do really nice artistic things. It's used in a lot of refrigeration systems to make condensers and such, and you can use it, like, you know, you think of stills with all the tubing that's made to condense the alcohol. But that's what it looks like. You can pass it around. Some of the edges might be ragged. I'm not going to use that, but you can feel free to bend it. You can break it. I don't really care. It behaves just like this copper. You use a tubing cutter to cut it. You solder it in the same way. However, with that tubing, it's soft enough you can grab it with what's called a flare block and drive in a swedge and actually make a connector for it. With this hard copper, we buy couplings, so that's what we'll be using here today. So I'm going to kind of go through this properly. So I've got copper here, and to cut the here, I'm going to pass this around to you just so you have things to look at. This is a good joint and a bad joint. Okay, this is a good joint on this side, bad joint on that side, so you can see what they sort of look like. And what you do to cut copper tubing to length is you can use a tubing cutter and just rotate and just give it like a little turn, maybe an eighth of a turn, and you get a nice clean cut. And you can try that later if you like. And you get a nice clean cut. You'll get a little burr there, so you can, there's a reamer attached to these, and you can clean that up. And also you can force them into an oval shape by the cutting operation, so I'll just pass that around. And there's smaller versions of that as well, like this, so it's just the same thing. It's got a cutter and a die. Okay, then I sand this, and usually the best way is to use a reamer, which is like a wire brush, or emery cloth, which has, it doesn't leave particles in it like sandpaper, so kind of clean that up. And I'm getting rid of the copper oxide, okay, because the flux that we're going to be using in a second dissolves copper oxide, but it doesn't do a good job getting rid of the lava. So sandpaper is not the best. You roll it up and get the inside. So again, I'm just scratching the inside. So sometimes you've heard like with PVC, you should sand the outside, and there's a lot of different thoughts on that. But with copper, you really have to. Then I'm going to put on a little flux, or a lot of flux. I was watching that. And flux is very cheap, so you don't want to get cheap on it. It's going to dissolve the oxide coating, and when you do your soldering, you'll see it bubble up, so it's sort of an indicator of the heat of the copper, so that helps too. So okay, put that in, and then I join these, and this is, there's a couple types of torches. Most of the torches you have at home you have to use a striker. You got to pass it around because it's a lot of fun if you haven't used it. This has got a auto igniter, so I can turn the gas valve and it will make a flame much nicer. Plus, if you notice, compared to what you have at home, the flame is a bushier flame, which makes it easier to solder with. And then what I'm going to do, you might want to get closer to this isn't dangerous, but I'm going to heat up the pipe. I want to heat up both sections of the pipe, or the connector and the pipe. And that's important, same with soldering. So I'm heating it up, and if it's a bigger pipe, it's really clean. If it's a bigger pipe, you actually have to do a process where you build out from the bottom because the solder will run out. So then you, oops, that's really I put a lot of